Welcome to this session on sign magnitude representation. Now, what is the sign magnitude representation? Normally, in mathematics or algebra, when we have to represent negative numbers, we will write a number like, say, as an example, the number 7, and we'll indicate that it is a negative number by putting a minus sign in front. Now, this minus sign is an indication that it is a negative number. But if we have to indicate a number that is plus 7, we will usually not show the plus sign unless it involves an operation before this number. So we could write plus 7, or we could simply write it as 7, and in both cases it will mean that the number is positive. But in a computer, the number 7 we know can be represented in a binary form, but the minus sign or the plus sign itself must be represented using some binary code. And that is where the sign magnitude representation comes in. So, in sign magnitude representation, the leftmost bit of a number will represent its sign, and the remaining bits will represent the magnitude of the number. So, as an example, supposing we have an 8-bit number, we have the bits B0, B1, B2, B3, B. This is a number, and in this a particular number, the leftmost bit, that is this bit, which is shown as S, this bit will be used to represent the sign of the number, and the remaining bits, that means bits from B0 to B6, these will represent the magnitude. Here bit B0 is still called as the least significant bit. Now, we will not call the leftmost bit as the most significant bit, because when we use the term most significant bit, the significance comes from the weight. But in this particular case, this bit does not have a weight, and this bit does not contribute to the magnitude of the number. It is only contributing towards the sign. So this bit will be either a 0 or a 1, which will be used to indicate whether the number is positive or negative. So the bit, which is the sign bit, does not contribute towards the magnitude, and it will only indicate whether our number is positive or negative. Now, if the sign bit is 0, then we take the number as positive, and for negative numbers we will indicate the sign bit as 1. So, and the rest of the bits, that means bits B0 to B6, will represent the absolute value or the magnitude of the number. And therefore, the entire bit pattern of these bits, these are 8 bits, the entire bit pattern can be broken up into two parts. Starting from the left, the first bit is the sign bit, and the remaining 7 bits, in this example, they contribute towards the magnitude of the number. As an example, let us consider a 4-bit number B0, B1, B2, B3, and in this, the leftmost bit B3 is the sign bit. So the minimum and maximum values we can calculate easily now. So we just need to remember that bit B3 can be either a 0 or a 1. Of course, every bit can be a 0 or a 1, but this bit B3 represents the sign of the number. So we will have two possibilities. One, bits B0, B1, B2, and these 3 bits, they can be 1. Each of these can be 1. That is the largest value a bit can take. And B3 can be 1, or the bits B0, B1, B2 can be 1, but the bit B3 is 0. So what this will indicate is, in both cases, the bits B0, B1, B2, these represent the magnitude. In both the cases, the bits are 1, 1, 1. But the difference comes in the sign bit. So in one case we have the sign bit as 0, and in the other case we have the sign bit as 1. And therefore we can say that the magnitude of this 1, 1, 1 is 7. This 1, 1, 1 is of course again 7, and therefore for 1, 1, 1, 1, that means this number, the value is minus 7. The minus sign that is shown here comes because of the leftmost bit, which is 1. This is the minimum value. And if we consider this number 0, 1, 1, 1, for this number, the 0 in the leftmost position is indicating that it is a positive number, and the rest of the 3 bits, that means these 3 bits together, indicate that it is a value having maximum 7. And therefore these 4 bits have been used up in 2 ways: one to represent the sign, and the other part to represent the magnitude. And therefore let us see how we can build up a general formula for this. Now in this case we have built up a formula, but it will be easier to understand if we go from the right and we move towards the left. Let us start. We said that the minimum value that we can have is -7. So let us start. -7 is the minimum value. Now this -7 can be written as minus 2 raised to 3 minus 1. Now observe this. 2 raised to 3 minus 1. So if I evaluate this part, this expression, I will get -7. But let us understand the logic behind 2 raised to 3 minus 7. 2 raised to 3 gives us 8. 8 minus 1 is 7, and this minus will give us -7. Now observe the logic behind this. This 3 is the number of bits that contribute to the magnitude. In this case we said that 3 bits are contributing to the magnitude. These are the 3 bits contributing toward the magnitude. So that is why it is 2 raised to 3. And -1, because when all the bits are 0 0, the magnitude bits are 0 0 0, the magnitude will be 0. And therefore this is 2 raised to 3 minus 1, and this can be further written as 2 raised to 4 minus 1. So we have essentially just taken this 3 and we are writing it as 2 raised to 4 minus 1. Now the question arises, why do we have a 4 minus 1 here? So the total number of bits that we have is 4. So that is the reason behind this 4. 4 minus 1 will give us 3. So we can write 2 raised to 4 minus 1 minus 1, and that is the negative sign. And therefore the minimum value can be represented in this method. And similarly, let us look at the maximum value. Now the maximum value is +7. This +7 can be written as, observe this, 2 raised to 3 minus 1. And this can be further written as, of course, to understand this, we are going from right to the left because that becomes easier. This becomes 2 raised to 3 minus 1. This can be further written as 2 raised to 4 minus 1, and this -1 is taken care of here. And therefore again this 4 represents the total number of bits which are present in our number. And therefore in general, if a number has n bits, in our example here n was 4, but in general if a number has n bits, we can say that the range of numbers is minus 2 raised to n minus 1. We can see that corresponds to this expression, minus 2 raised to n minus 1. N is the total number of bits, and minus 1, 2. And now check this, 2 raised to n minus 1 minus 1, and here we have a negative sign. Here there is no sign, which is essentially saying that it is a positive number, and therefore the values change from this range to 2 raised to n minus 1. So this becomes the range of numbers which we can represent using the sign magnitude form. Now there is a disadvantage with sign magnitude representation, and that disadvantage is that there are two representations of 0 in the sign magnitude representation, because we can write 0 as 1 0 0 0 or as 0 0 0 0. So we saw that these 3 bits will contribute to the sign, to the magnitude, and the leftmost bit is only contributing towards the sign. So we have a situation here where we could write 0 followed by 3 zeros. This will give us the value of +0. Or we could write 1 followed by 3 zeros. This will again give us the magnitude 0, but the sign will be negative. Now we do of course know that 0 does not have a negative or a positive value. 0 is only a single value. So this is something we know, that if we were to take a number line, and on a number line we would represent 0 here, then we would represent +1, +2, +3, and then we would go on the other side, -1, -2, -3. So We have 1, 2, 3. They can have a negative equivalent -1, -2, -3, but 0 is having a singular value. So this is a disadvantage with the sign magnitude representation. And it's a major drawback, right? The other drawback is that addition and subtraction using sign magnitude is complicated. And it is complicated because when we add or subtract the binary form of a positive number and a negative number, it does not give us the correct answer. Another major drawback that we have with sign magnitude is that the largest possible number that can be represented is reduced. So one of the bits has been used up to represent the sign. So for example, let us take this case. We have an 8-bit number. This 8-bit number has 1 1 1 1 1 1 1 1, and this has the value 255. This is assuming that we are considering it as an unsigned number. This is an unsigned number. That means all bits are used to contribute to the magnitude. So this is 255 in decimal. But if one of the bits we use up for the sign bit, that means if I want to represent this number as a positive number, then I'll have to keep this bit as 0, and that leaves us with only 7 bits, 7 ones, and this 7 ones gives us the decimal value 127. And therefore when we are using the sign magnitude representation, the range of numbers is greatly reduced. Of course, we must remember that in this first example that we have taken using 8 bits, here this 1 is not being used for the sign bit, it is being used to represent the magnitude. So, and if we were to take this value as 1 1 1 1 1 1 1 1, then this would represent minus 127, because these 7 bits would have contributed to 127, the magnitude, and this would have been the sign bit to show that this number is a negative number. Now that would be if we were to take it as a sign magnitude form. So we see that the range of numbers is greatly reduced. Let us take an example. Convert the number 33 of decimal to 8-bit sign magnitude representation. Now let us observe this 33, we will convert it to the binary by the 2's division by 2 method, and we will get the value 0 1 0. So this is the magnitude of 33. 0 1 0 0 0 1. We can verify that this is 33, and since we have a positive number, we take the sign bit as 0, that is the leftmost bit, and therefore the high bit we write it as 0. Let us take another number. Here we have the number minus 33. We want to represent this as an 8-bit sign magnitude representation. Again, we will first take the number 33, convert it into the binary form, and we will have the same binary value as we had in the earlier example. This becomes our binary value, but in this case we write the sign bit as 1 because we want to represent this as a negative number. So we say that the high bit is 1 since the given number is negative. This should be negative. Sorry, this should be negative. So the high bit is 1 because the given number is negative. Let us take this third example. Here we have to find the binary equivalent of minus 22.5625, and we want to represent this in sign magnitude representation. Now again the solution will be simple. The minus sign indicates that we will have to take the sign bit as 1. So we break up this problem into two parts. First, we will convert 22 into binary using the weights method, or we could use by division by 2 method. In either case, we would get 22 as 10110. This is only the magnitude, and therefore now we will move on to the fractional part, 0.5625. Now this 0.5625 we've already seen in decimal to binary conversion. This can be converted into 0.1001. So we have the decimal part, the fractional part, and we have the integral part of the given number, and therefore this minus 22.5625 is equal to, for the negative sign we put 1 here. This will indicate that it is a negative number. Thereafter we have 001, so we have 001, 0110. So basically it is just this number. So if we start from the least significant bit here, 01101, so there we have 01101, and these two bits are padded to this. So this has been padded with leading zeros, and therefore we have 1001, 0110, and that followed by the binary point, and then we have 1001. So this becomes the equivalent value for the negative number. Let us take this fourth example, and here we are given a binary number. So it's a reverse of the earlier examples. Here we are given a binary number, and we are told that this number is in the sign magnitude form. So we have to calculate the decimal value. So we start, since the number is in the sign magnitude form, the leftmost bit will indicate the sign, and the remaining bits will give us the magnitude. So we have the first bit, that means this bit 1 here is our sign bit, and now we concentrate on the remaining bits. So the remaining bits are 0, 1, 0, 1, 1. This can be converted into the decimal, and let us first write down what are the weights. So the weight of this, starting from the least significant bits, the weights are 1, 2, 4, 8, 16. Wherever we have the 0 bits, we are going to strike off the weights, and therefore we are left with now 8, 2 and 1, and therefore the magnitude of this is minus 11, and this 1 indicates that this number is negative. So this bit 1 is to indicate that it is a negative number, and the rest of the bits are giving us the magnitude of that number. And this is how we convert from decimal to binary and binary to decimal, assuming the sign magnitude form.